Go ahead and read problem 7-62, including letters A and B. Hit pause and then play when you're finished. So in the previous problem, we proved that the opposite sides of a rhombus are parallel. In this one, we're investigating the diagonals of a rhombus. Now we're not going to do letter C, where we write a flow chart to prove that triangles are congruent and build from there. So we're going to make this problem a little bit shorter. We're simply going to use the hinged mirrors to prove our properties. Let's do so. So here we have our hinged mirror, our colored paper. And if you remember, if we make this angle wider or more narrow, it changes the number of sides in the shape showing in the mirror. Now, what should that central angle be in order to create a rhombus? Well, I'm going to take a note card here, and we should know that the corner of a note card is 90 degrees. And when I do this, what shape is formed? We can see that that forms a rhombus. Well, is it always going to be a rhombus? Let me turn the mirrors like this. Still a rhombus. Still a rhombus. So that tells us that the diagonals of a rhombus are perpendicular. Okay, what else can these mirrors tell us is true about the diagonals of a rhombus? Well, let's look and see what happens when I add a tick mark here. You can see it's reflected across, meaning at the intersection, that diagonal is cut in half. It is bisected by the other diagonal. Well, let's see if the same thing is true when I put tick marks on this one. You can see that both diagonals bisect each other. So not only are diagonals perpendicular, but they also bisect each other. Let's now add that to our toolkit. So first, add the diagonals to your rhombus by connecting one vertex to the other, opposite vertices, that is. So we just proved that diagonals are perpendicular and they bisect each other. So we'll add that to our properties. And there we go, properties of the diagonals of a rhombus.